Hello everyone and welcome aboard this video. So today we are dealing with the RSI divergence. I've seen a lot of strategies using this indicator and claiming the potential benefit of using it in trading strategies. Before we continue, I've put a download link in the description where you can get the Jupyter notebook file I have used for this video. So the way we will do this is first by writing a piece of code that would detect the minimas and the maximas of the price and also those of the RSI. So these are marked by the purple points that we are seeing on this graph here. And the algorithm I've used for this is that whenever I have a high of a candle that is higher, let's say, than 5 neighboring candles from each side, then I consider this as a maxima. Similarly, if I have a low value of a candle that is lower than 5 candles on the left side and 5 candles on the right side, then this is considered a minima. You can of course change these numbers. If you want to have an extreme minima, you can say I would like my low to be lower than 10 candles on the left and 10 candles also on the right. In this case, you can only detect like strong minima or strong maxima positions. So this is one way of doing things. There are different ways, probably more performant, but this one is very convenient for numerical methods. So it's very easy to put into a code. And actually it works more or less fine, except for some cases where, for example, you have not very important dips. For example, this one here, this point, it's like a very low dip, but it's also detected as a minima with the algorithm we are using. Similarly here, for example, you have a local maxima that is detected by the algorithm. However, it's merely one candle that is showing a high value. But since this high value is higher than the 5 candlesticks on the left and the 5 candlesticks on the right, it's considered as a maxima by our algorithm. So it's not perfect, but it works more or less fine, and we're going to use this for the rest of our program. It works better for the RSI because we are not using candles. In fact, we are using simply values, and this is more compatible with the algorithm we are using to detect minimas and maximas. And this is an example here. So we have a maxima of the RSI at this point. We have a minima at this point. These are the purple points that we are seeing on this graph. Then we can use these points for a linear fit on the price graph. In other words, we're going to fit the maximas together and the minimas together, and we will have 2 different slopes, as you can see here. So for example, if I have my present candle at this point, I will look back, let's say, to 20 candles in the past. I'm going to check the maximas and the minimas. Then I'm going to fit the minimas into one slope. This is the green slope we are seeing here. And the maximas are going to be fit into this purple slope. In other words, these slopes are the straight lines that would go through the data with the closest distances to the points of maximas and the points of minimas. So at the end, I will have 2 different slopes for the price, and I'm going to check if those slopes are negative. If it's the case, then I know I have a downtrend. And of course, in the opposite case, if I have both slopes are positive, they are pointing upwards, then in this case, we have an uptrend. So once we decide which is our trend direction, we can apply a similar approach to the RSI, maximum points and minimum points, fitting those into a linear slope. More specifically, in the case of a downtrend, we are going to look for the minimas, and in the case of an uptrend, we're going to look for the maximas of the RSI and fit these into a new slope. Then also for the RSI, when we have set our slopes, we can compare the values of these with the slopes of the price. So for example, here we have slopes of the same signs, meaning both slopes are positive, meaning we have higher lows of the price with time, and we have higher highs of the RSI that are pointing upwards. So in this case, we don't have a divergence because both slopes of the price and the RSI are pointing in the same direction. And the same thing we are observing here. We have a price downtrend, meaning the slopes are negative, both of them, for the maximas and the minimas. And at the same time, the slopes of the minimas of the RSI are also negative. So we have both price and RSI moving in the same direction. So also in this case, we don't have a divergence. A divergence happens when we have different signs of the slopes between the price and the RSI, meaning either the price is a downtrend but the RSI slope is a positive, or it's the opposite. We have a positive uptrend for the price and the RSI slope is negative. So there are many different ways of thinking of this. I've seen some strategies checking the maximum points of the RSI for the price downtrend and the minimum points of the RSI when we have a price uptrend. And honestly, I haven't seen any comparing the slopes of a polynomial fit. It's simply a numerical procedure that we are introducing here to allow us to take more than 2 maximas or minimas points at once. So imagine we have 3 points or 4 points. Here numerically, the easiest way is simply to fit those into a slope and then use this slope as an indicator. While the strategies described online on different resources, they are usually used for manual trading, and so they are describing the trend of different points, mainly 2 consecutive points if they are pointing downward or an uptrend. But definitely they don't talk about a fit or a polynomial fit between more than 2 or 3 points. Which leads me to the next idea, where we can simply compare the last 2 minimas and maximas of the price and the RSI. In other words, if I have my candle of interest here, for example, I'm positioned here today, I'm looking backwards, I'm checking it's an uptrend, so I'm looking at the minimas of the price, I'm looking, for example, at the minimas of the RSI, but in this case, I'm only taking the last 2 points of interest of both the price and the RSI, and I'm checking the difference of levels between these points. So here we have a higher high, here we have a higher high, so we don't have a divergence. So we're not really using a polynomial fit here, just comparing the difference between 2 consecutive minimum points or 2 consecutive maximum points. This I have seen more frequently in the descriptions of this specific indicator, meaning the RSI divergence. And in this video, I'm going to show you both methods. We are going to code this divergence using a slope fitting many extremum points, or simply limiting our search to 2 points comparison. Just a quick message: if you are enjoying these videos and if you find these helpful, just a couple of seconds to press the like button. It would be of great support for the channel. And again, if you have any comments, it would be nice to have a feedback on the content of these technical summaries. Okay, now let's jump into our Jupyter notebook file and see how we can code all of this in Python. So this is our Jupyter notebook file. I'm starting by importing pandas, and then we are reading our data from a comma-separated value file. This is the euro versus the US dollar data, the 4 hours candles, and going from 2003 and up to 2021. So if you are familiar with my previous videos, you would know that we have used this same cell multiple times now. It's simply reading the data, defining the columns, titles, and cleaning the data from volumes that are equal to 0, because these are the days where we didn't have any trades and we are not interested in missing data in our case. We are resetting the index and just printing the first 10 lines of our data frame to see what we are dealing with. So we have our candles information, the opening, high, low, close price, and the volume column. We have the time column, and we have the index of the data frame. Then I'm importing NumPy because it will be needed. And I'm importing also the pandas_TA technical analysis. This is a module that contains predefined functions that we can call, defining the technical indicators, such as the RSI or other indicators. So I'm defining a new column in my data frame called RSI, which is the result of the TA.RSI function applied to my DF data frame. And the length is a standard value that I'm using, 14 here. We could of course extend this to whatever we would like. I'm just leaving it like this for the moment. And here I redefined the RSI function again. The reason I'm doing this is that I was curious. There are 2 different ways, or probably more different ways, to define the RSI. This one that is provided by the pandas_TA module uses the exponential moving average instead of the absolute price. While if you are familiar with the formula of the RSI, you can simply use the price as is, the closing values of the candles. The visual difference between these two methods is that when you use the exponential moving average or any moving average, your RSI is going to be a bit smoothened in the sense that your extreme values will be closer to the center than the case where you are using the price. So in this case where we don't use the moving averages, we are going to have more extreme values of the RSI. For our study, it wouldn't make much of a difference. I simply was curious while I was building this code, and I included both methods. So if you are curious like me, you might want to experiment using these two functions. I'll just leave it here for you in case you want to experiment on this. So now we can execute and add our RSI to our data. Obviously, the first 10 rows don't have any values because we need at least 14 candles before we start having reasonable values for the RSI. We are using the length parameter, which is equal to 14 here. So in other words, if I'm going to print the first 20 candles, then starting from the 14th candle, I will see that we have an RSI value. Then I will try to plot a random slice of my data with the RSI. These are our candles. This is our price movement, and this is the RSI. And we can see that the values are reasonable in the sense that when the price is going down, we have a low value of RSI. And when we have an uptrend of the candles, we have a raise in the RSI values. Then I'm going to define a new function called pivot ID that would detect the pivot points within my candle data. So it takes a data frame, it takes a candle ID, like an index of the current candle I'm interested in, and the number of candles preceding the candle that I'm going to test, and the number of candles coming after the candle that I'm interested in. And I'm going to check if the L minus N1 is less than 0, meaning if the current candle is so close to the beginning of my data frame that I can't look to N1 candles preceding it. So if I go L minus N1, I'm negative, so I'm outside of the boundaries of my data frame. Same thing if L plus N2, meaning I'm at the end of the data frame, is greater or equal than the length of data frame, then I'm returning 0. So I'm discarding the edge cases here just to avoid some hassle. Then I'm considering that the current candle is a pivot ID low and is also a pivot ID high. And I'm going to check for I in range between the L minus N1 and the L plus N2 plus 1 in order to include the candle of ID L plus N2 in my calculation. I'm going to check if the data frame low value, meaning the lowest value of this candle, is greater than any of the lowest values of its neighbors between L minus N1 and L plus N2. If it's the case, then this candle is not considered a low value anymore, so it's not a low pivot point, and I'm putting the pivot ID low variable equal to 0. Same thing, I'm testing if any higher value is present in the neighborhood of the candle ID L, which is the candle I'm testing. If it's the case, then this particular candle is no longer the highest value or the highest candle of its neighborhood. And in this case, it's not considered a pivot point, and therefore the pivot ID high is equal to 0. So after we have checked all the candles in the neighborhood of the candle L, I'm going to see if I have a pivot ID low and a pivot ID high, meaning if this candle is both higher and lower at the same time of all the neighbors' candles, then I'm going to return a category number, which is number 3 here. Otherwise, if it's a low candle, I'm returning 1. If it's a high candle, I'm returning 2. And in any other case, I'm returning 0. In other words, this function takes a candle, takes a data frame, takes a range between N1 and N2, number of neighbors, before and after the candle L, and it would return a category for the candle L. Is it a pivot ID high? Is it a pivot ID low? Is it both or is it neither? Then I'm defining another function called RSI pivot ID. It works exactly the same as the pivot ID for the candlesticks, but this time it's for the RSI. We don't have a high and low values for the RSI. It's simply one value. So we modified the function accordingly, and we also preserved the same types of categories that we can obtain as a return value of this candle. Now we can use these two functions. I'm defining a new column in my data frame called pivot, and for each row, meaning for each candle, this column will contain the category of the candle. Is it pivot ID high? Is it a pivot low? It's neither, or is it both? So we are putting all of this in a new column in the data frame, and we are applying the function pivot ID that we have previously defined on the current row using 5 by 5. So I'm taking 5 candles before the candle of interest and 5 candles after the candle of interest. You might want to consider experimenting on these if you don't like the results. Then for the RSI pivot, also we are defining a new column in the data frame. We're applying the RSI pivot ID function, providing the same type of information. And now I will define two new functions. These functions are not mandatory for the analysis. However, they are for the visualization of what we are calculating. And I would like to visualize something like this. I would like to have points on the pivot candles just to identify these on the graph and be able to visually analyze and see what's happening. In order to do so, I will define these point positions, what's called point positions in my data frame. I'm applying these two functions. So these functions work as follows. The first one is point position X. It's provided a row or an index. It's going to look for the pivot column. If it's equal to 1, we're going to position the point below the lowest value of the candle. So if we have a pivot 1, meaning we have a pivot low, in other words, this candle is the lowest among its neighbors, then I'm going to put a point at the position of the low minus something like 1 exponent minus 3, for example. Then if it's a pivot high, I'm going to put the point slightly above the highest value of the candle. If we have none, if it's something, it's not a pivot point, then we're going to return a numpy nan value, which is not really a numerical value, because we would like to discard this in our graph. Then for the RSI, it's the same. If it's a pivot low, we are returning a position of the RSI, but -1. So we are positioning the point just below the RSI value. If it's a pivot high, we are positioning the point slightly above the RSI value. And now I can run these two functions and add these two information columns into two new columns in my data frame. Okay, so I have this cell. I'm going to increase the points number. Let's put 5, for example, so it can be more visible. I'm taking a slice of my data frame. I'm plotting the candles, and then I'm adding the points related to the positions of the pivot candles, pivot high and pivot low. And we can define the size of the markers and the color. Of course, these are aesthetics. Let's run this and see what we are looking for. So this is how our points will look like. And in order to just verify if things are working well, I'm going to zoom in into a part of the slice and see how our algorithm is behaving so far. So we have a pivot high at this point. We have a pivot high at this point. Here we have a perfect detection of a pivot low. Then we have these points here. Somehow it's working well. You have also, you always have these kind of exceptions. For example, this one here, this candle right here, it's not really a big high. It's not really a rejection point, but since it's higher than its neighbors, the 5 candles before it and the 5 candles after it, then this particular candle is considered also a pivot high. This one is also a pivot low. So these are not really pivots. It's not really a dip, but they are detected nevertheless by our algorithm. We can try to do the same thing, plotting also the candles, but adding also the RSI with the points. And if we execute this, we're going to get something like this. I'm going to increase the size again of these markers because it makes reading things easier for me. Yes, so it works more or less fine for the candles, but it works perfectly fine, I would say, for the RSI. Because the RSI doesn't have these high and low values, you have a point, like an absolute value somehow, and then it can be detected if it's a low point or a high point versus the neighbors of the RSI values. So great, now we have our algorithm that detects the peaks, the high pivot points, the low pivot points with the for the candles and also for the RSI. Okay, now at this point we need to define the number of candles we are taking into account to check for the pivot points before the candle of interest, which is the candle ID. And I'm looking to 60 candles before the candle ID. I'm going to detect the maximas and the minimas within this region and then try to fit those into slopes to detect the divergence of the RSI. So let's define 8 NumPy arrays. 4 are the maximas and the minimas values with their coordinates, or probably their indexes at this point, for the minimas and for the maximas, for the prices, and the same thing for the RSI values. And then for each candle in the back candles region, we're going to test if we have a low pivot point. If it's the case, we are going to append its coordinates into the minimum and the XX minimum of the NumPy arrays that we have predefined. And the same thing, we're going to test if it's a high point, and we're going to add the values in the corresponding arrays. Same thing for the RSI, if it's a low RSI pivot point, and if it's a high RSI pivot point, we're going to add all these points, their coordinates, into the corresponding NumPy arrays. Then we're going to fit those into 4 different slopes, 2 for the candles for the prices and 2 for the RSI values. Remember that we have the minimas and the maximas, so it makes 2 slopes per graph. And now we can plot these. So we can plot these on the candles graph and also on the RSI graph. And if I run this, we can check together what is going to provide us. So I've printed the slopes at this point just to verify the magnitude of the values. It also helps me to have an idea what kind of numbers we are talking about. And here we have our results. As you can see, we have 2 descending slopes at the candlesticks figure. So this is a downtrend that is detected. Same here at the RSI, we are detecting a downtrend. We have 2 different descending slopes. So my functions are validated. They are working perfectly fine so far. Let's continue and see what we can do with this. If you are intending to use this for trading, you would want to generate a signal from this, from the divergence. So I'm putting all what we have defined before in a function that is called divergence signal. It takes a row, like a candle of interest, and then it takes the number of back candles to that we have to look at just to detect if we have divergence of our RSI. And within this function, I'm defining exactly the same methods I have used before. We have just used for the plotting of our slopes of the trend and the slopes of the trend of the RSI. We just have to pay attention that when we don't have more than 2 minimas or 2 maximas, we can't fit any slope through one single point. So in this case, we are returning 0, and this is what we are testing here. But then if it's not the case, we can fit those into the 4 slopes that we have previously explained. And then I'm going to test if my slope minima of the price of the candles is greater than 10 to minus 4, meaning it's positive. And the maxima, also the same slope of the maximum points, is also positive. It's also greater than 10 to minus 4. But at the same time, so we have an uptrend in the price here. But at the same time, my slope of the maximas of the RSI is less than minus 0.1. So it's a negative slope. It's going down. This is where we have a divergence. The price is showing higher highs, but the RSI is showing lower highs. And this is where we have a divergence in the negative sense, so we are returning 1. So we would expect the price probably to switch back and follow the RSI and follow a downtrend instead of the current uptrend. Then we have the opposite case where we have the slope of the minimas of the price is negative. So the price is going down. It's showing lower lows. And at the same time, the price is showing lower highs. So it's definitely a downtrend. And the RSI slope of the minimas is positive. So the RSI lows are showing an uptrend reversal. And in this case, we are returning 2 as a signal. If we don't have any of these two cases, we're simply returning a signal which is equal to 0, meaning we don't have any divergence. We don't detect anything special at the current candle position. And I'm adding this column to my data frame called divergence signal using the divergence signal function. I'm taking 30 back candles. I'm just looking at 30 candles before the candle of interest for the moment. And we can run this and check what it's providing in terms of data. So we should have at the end the divergence signal for each row. At these visible signals are 0 for the moment, but definitely we have different values in our data frame. We can check it out by filtering all, for example, all the signals where it's equal to 1, and we can check it out. Let's go at the end. So these are all the 1 signals. You may notice something that when the signal is settling, you can have a series of rows like for different candles. Here we have 71, 72, 3, 4, 5, up to 90. So it seems that with our input parameters that we have used in our algorithm, when a reversal or a divergence is detected, it's detected for a certain period of time, not just for one single candle, but let's say for 2 or 3 days. You have this divergence settling in, and it opens the opportunity for you to choose a good entry point if you are wishing to enter the market. And you may have noticed that I simply took a slice of the big data frame from 0 up to 500. So it's only 500 candles. The reason behind this is that it takes a lot of time to compute this, not an excessive amount of time, but it took like 5 minutes for my CPU to process this, because for each candle we have to look back like 30 candles, check the minimas, check the maximas, fit those for the RSI at the same time for the candlesticks. So it seems like it's starting to get heavy on the CPU. Of course, when you settle for a good indicator, you can launch it for as many candles as you like, and then just wait half an hour for it to complete the computation. Now, if you didn't like the fact that we are fitting the minimas and the maximas into slopes, and you would like simply to compare point difference of levels, at this point we can do something different. We have a modified divergence signal 2 function. It's almost as the previous one, with slight differences. We are going to use the closing price value and the position or the index of the closing price value. And we are going to fill those with the maximas, the minimas of the candles and also of the RSI. We are fitting the closing price of the candles into a polynomial fit, into a slope. This will define the trend of the price. So if we have an uptrend, for example, meaning the slope of the closing price of the candles is greater than 10 to minus 4, and at the same time we have less than 2 points, either with the maximas of the RSI or the maximas of the price itself, then we can't test for a divergence, because we don't have enough points, we don't have enough maximas. And the opposite case, if we have a negative slope of the closing prices, so we have downtrend of the candles, but at the same time we don't have enough RSI points, minima points, or enough minima points of the candles, also we're going to return 0 because we can't test for the divergence. Now, if we do have enough points, we are going to check, first of all, the nature of the trend. So if we have an uptrend, we are going to test if the last element of the maximas of the RSI is less than the previous element of the maxima of the RSI. So these are the last 2 points of the RSI maximas, and we're going to check if they are showing a decreasing level. And at the same time, we are going to test if the highs of the price itself are showing increasing highs. If it's the case, we have a divergence and we are going to return 1. And the opposite case, if we have a downtrend, we are going to check if we have an increasing lows of the RSI and decreasing lows of the price. In this case, we return 2 as a category. It's a new divergence category. Otherwise, if we don't have any kind of detected divergence, we are going to return 0. I'm going to add this as a new column into our data frame, calling it divergence signal 2, applying the divergence signal 2 function with 30 candles to take into account. Remember, our slice of data frame contains 500 different candles, so from 0 up to 500, and we are going to try to add this signal to our data frame. It's right here, the last column, and we are going to filter, for example, the signals that are equal to 2. So when do we have a divergence going up? So let's check our signals. I'm filtering here the signals that are equal to 1, meaning we have a divergence and the RSI is showing lower values. So probably a reversal towards a downtrend. And the candles concerned in this signal 1 are between 72 up to 90, 91. So we have a few days where the signal is showing. If we want to calculate these, it's around 20 candles times 4. It's the 4 hours candles divided by 24. So it's a signal that is settling within, let's say, 3 to 4 days. So you're going to have the same signal over 3 or 4 days, which gives you plenty of time to choose your entry point if you want to join the market. Then we have another series of signals between 268. Well, it's one signal, and then another one showing at 358, the index bar 358 up to 369. So also around, I would say, 1 day, 2 days. And we are testing a period from 0 up to 500. So it's around 2 months, 2 months and a half, 3 months. So it's not many. If we are counting the number of signals effectively, here we have 2 signals, 2 periods of signals in 2 months, and yeah, 1 buying signal. So in total, expect like 1 to 2 signals per month using the 4 hours charts. And we can try to plot these actually. We can try to plot, let's say, the candle 80. Let's go up where we can plot this. Let's check the candle ID, let's say number 85, and see what's happening. So indeed, we have a divergence, higher highs of the price. We have also higher lows, so we have an uptrend, while the RSI values are showing a downtrend. So the algorithm is correct. Everything is working perfectly fine, and we can see that it is a detected divergence. We can confirm this if we consider an average slope procedure. Even if you take 2 different points, let's check the last minimas here of the price. We can see that these points show a slightly uptrend. We have higher lows from the candlesticks, while here we have lower lows from the RSI. Also, these points here, they are showing a slight increase in value between these points. So we have 1.17463 and then we have 1.17553. But then the maximas of the RSI are showing downtrend, so it's lower highs of the RSI. So we have a divergence. This area is showing a divergence, no matter what method you are using. But then I guess what's most important is what happens next to the price. Now, I'm not very familiar with strategies using RSI divergence. I just built this indicator so we can research on this together. If you have any ideas, and especially if you have an experience trading this particular indicator, don't shy out from leaving comments. At this point, I've read so many strategies using this indicator. Some of them are looking for a specific candles patterns in parallel when you have an RSI divergence pattern, or some of them are dealing with the RSI divergence at the same time looking for support and resistance levels happening. So anyway, this is an excellent example. Here we have resistance and support level. Look at it bouncing at this point and going back. Look at the price bouncing twice at this same level, 1.16. And we do have a divergence. Now, I have seen somewhere that if you have an uptrend and the RSI is showing lower highs, it means that the price trend is still ongoing. There will be a renewal of the same trend and the price is going up. And exactly here, it's confirmed by the fact that the price is bouncing over a support. I think if we can look also at these candles here, we can see some kind of a rejection confirmed by a long upward candle. So if we combine 2 or 3 different indicators, I think they can confirm the trend is still going up. And this is what happened for the price. We could put the stop loss definitely below the support level and the take profit somewhere around twice or 1.5 times the stop loss distance. Okay, so that's it for this video. I hope you guys found the information helpful. If so, please leave a like, subscribe. It will be of great support for this channel. If you have any comments on proven strategies using the RSI divergence, you can share those with us in the comments section. Until then, safe trading and see you next time.